Hello, Charan. How are you? Hi,
Fine, sir.
Lokesh. Good evening. How are you?
Fine, sir.
Right. Okay, let's just wait for a minute and then we'll start. Okay, should we start now? Actually, let's start. So we were in the NLM part, isn't it? So let's continue there. Okay. Okay. So NLM part, what we discussed was that how do we calculate the impulse and how do we calculate the average force acting on a particle? Okay. So if they are asking the force, what we will do it? We will find out the change in momentum divided by what? The time taken for that change in momentum. Okay. And if they are asking the impulse, then only what is enough? Only the change in momentum is enough for what? For the impulse. Why? Because impulse is the change in momentum of the particle. Is that clear? One more way we can find out the impulse. Sometime the question will give you what? A graph. Okay. Let's say in this example, what is given to us? There is a graph given between force versus time. Okay. What kind of graph is given? The graph is given as force versus time. You know that what is the area is going to represent? Tell me. Something like this kind of graph is given to us. Let's say this is 0 second. This is 5 second, this is 10 second, and this is 15 second. And this one, let's take it as the 20 Newton. So can I say that from the similar triangle, this is also going to be minus 20, isn't it? So if I ask you, find a change in momentum, find change in momentum, okay? Change in momentum of the particle, if I'm asking, what you will do it? Change in momentum of the particle if we are trying to calculate, find change in momentum of particle they are asking in the question. So how do we calculate change in momentum? And change in momentum can be also called as the impulse, na? Please tell me. Change in momentum, we can also call it what? The impulse. So in the question, if they are asking the impulse or they are asking in the question, what is the change in momentum? Actually, they are asking what? The same thing in the question, isn't it? So to calculate that, should we calculate what is this area? Let's call this area as A1 and this area as what? The A2. Understood? This is A1 and A2. So if I want to calculate the impulse, okay, or if we want to calculate change in change in momentum, should we calculate both the area? Isn't it? And A1 will be what? Positive and A2 area will be what? It will be negative. How much is A1? Half into 10 into 20. So that is 100. And what is A2? Just check it once. Is the A2 is half into 5 into 20. So that is coming how much? 50. That means, can I say impulse means change in momentum? And that we can get it from where? From this area part, isn't it? Area under this graph, we can use it to find out the impulse or change in momentum. So how much it will come? Will it come plus 100 will come? And the below area what we take is the negative. So what is we are getting? 50. What is the unit of that one? Kg meter per second. Is that part clear? Please tell me. Understood this question?
Yes, sir.
Right? So in the question, whether they are asking the change in momentum or they are asking in the question what is the impulse, what we should do, we should find out using what? Using the area. Actually, sometimes they will give you force as a function of time. Okay, sometime what will happen? Sometime in the question they will give us the force as a function of time. Can we find out what will be the impulse acting then? Please tell me what we will do it. Like, let's say in the question is given to us, force acting on the particle is what? Or force acting on the particle is given to us, let's say 2t plus 4 Newton. Okay, they're asking again same question. Find impulse acting on the particle. Okay, impulse acting on the particle. Okay, for 0 to 4 second. So in this duration, how much impulse has acted on the particle? That's what they are asking in the question. Is that clear? What we should do it? Up here, instead of plotting the graph, impulse means what? Impulse means, can we write it? Impulse is going to be integration of f dt. We can write it, isn't it? Impulse we can write it as what? Integration of f dt. Area is also same thing. F dt integration is nothing but the area under force versus time graph only. Understood? So here impulse can be write it integration of f dt, because here the function of force is given. It will be better if I integrate that, isn't it? If graph is given, it's better to find the area. If function is given, then it is better to find what? The integration. So what we will have? 2t plus 4, and let's integrate that with dt. And what duration they ask in the question? 0 to 4 second. So that means what is the integration will come? So 2t dt integration will come how much? T dt means t square by 2 will come plus 4. Dt integration t will come, and what is our limit? 0 to 4. So if you simplify it, 2 will get cancelled out. Let's put the limit. The upper limit 4 square plus 4 into 4 minus lower limit. If I keep it, we will get it 0. The 16 plus 16 to 32. And what is the unit of impulse? Kg meter per second. Understood? Kg meter per second, or can I also call it 32 Newton second? Please tell me. This is the impulse unit or change in momentum unit, can be also written as what? Newton second also it can be written as. So please tell me, understand about the impulse force using what? Rate of change of momentum to calculate the force. Understood up to this? Please tell.
Yes, sir.
So
Yes, sir.
now we are okay. So let's discuss now what are the different type of forces going to be involved in this chapter. Okay. So there are few common forces which we have to draw it in the free body diagram. Okay. So let's try to understand the type of forces. Okay. What are the different type of forces we have? Okay. To see all the forces we have now, we can divide all the forces into two type. What are the two type? Contact type, and the second one is what? The non-contact type. Okay, non-contact type. Contact type, can you tell me the example of contact type forces? What are the example of contact type forces? What are the example of contact type of forces? Tell me. Can we say that normal reaction, normal force is a contact type force, right? Because for applying the normal force, we need the contact between the two bodies, isn't it? Next, tension force created by the string, that is also a contact type. And whenever we connect an object, let's say this pen is there, if I hang it with the string, what will happen? In the string, the tension force will be acting, isn't it? Or the string will be applying tension on the body. Next, can you tell me other forces? Spring force. Hannah, spring also apply what kind of force? Because of the contact with the spring. What other force? Friction force, isn't it? So these are some of the examples of what? The contact type of forces. Can you tell me the example of non-contact type force? And there is another name of non-contact type force. Non-contact type force is also called as field force. What it is called as? It is also called as the non-contact type, or it is also called as what? The field force. Why it is called as field force? Because to apply these type of forces, we don't need the contact between the bodies, right? So what they do, how they apply the force on each other? So when these type of forces arise, what it does, it creates a field in its surrounding. Understood? And when any other object enters that field, then that object experiences the force due to the other one. So what are the example of those type of forces? Can you tell me? Can you tell me few of the example of field force? The gravitation force, very common example.
Magnetic
Electrostatic
force.
force, yes. Electrostatic force, magnetic force, right or not? So these are the example of what? The non-contact type of forces or field force. Okay, so in this chapter we are going to focus more on normal force, tension force, spring force, friction force, and gravitation force. Clear? This chapter is going to have mostly these forces involved in our question. Okay, normal, tension, spring, friction, and gravitation. Is that clear? Electrostatic force, where it will come? In the electrostatics, isn't it? Which we have discussed already, isn't it? Electrostatic also going simultaneously, na? In that one, we have seen the force between the two charged particle, force between a charged particle and a rod, isn't it? So those were the example of what? The electrostatic force. There also the contact is not needed between the charged particle. Okay, clear up to this? So now let's discuss one by one these forces. Okay, so first we are going to discuss about the gravitation force. Okay, gravitation force or gravitational force is what? It is the simplest one. Why? Because its magnitude is always fixed and its direction is always fixed, isn't it? So can you tell me what is going to be the gravitational force? Tell me what will be the value of gravitational force and what will be the direction of gravity force. So if any object is there of mass m and it is kept near to the earth's surface, keep in mind where? Near to the earth's surface. Matlab, whenever we will discuss, okay, a block is hanging with an string. So that must be the near to the earth's surface, isn't it? Or these are the particles there. So in that case, what will be the gravitational force acting? If m is the mass of object and g is acceleration due to gravity, so how much will be the gravitational force? It will be mg, and which direction it will be acting? Mg, acting in which direction? Vertically downward direction. Understood? What direction it will be acting? Vertically downward direction. So gravitational force is the simplest of all. So whenever we want to draw the free body diagram of an object and we want to show the gravitational force acting on the body, how we will show the gravitational force acting on a body? With m into g. And what will be the direction of that force? The direction of gravitation force is always going to be which direction? Always in the downward direction. Is that clear? The first force, please tell me. First force, the gravitation force, is the simplest of all the forces. Okay, please tell. Clear about the gravitational force?
Yes, sir.
Yes, sir.
Next is the normal force. Okay, normal force, name itself suggests that it's going to be normal. So normal to what? It will be normal, but normal to what? Tell me. So see, normal force, whenever it will act between the two bodies, the two body must be in contact with each other, isn't it? So the normal force always act what? Always act perpendicular to contact surface. Understand which direction it acts? It always acts perpendicular to what? The contact surface. And the nature of normal force is what? It always try to push the body. It always try to do what? Push the body away. Understood? So whenever we have to draw the normal force on the body, what we will do? We will always apply the normal force how? Perpendicular to the surface of contact, and whichever direction the body is getting pushed na, in that direction we will apply the normal force. Please tell me, understand the direction of normal force? So, but what is the magnitude? Magnitude of normal force by any kind of formula we cannot see. How do we find out then? Then we have to check it. What is the situation? And as per the situation, the normal force will keep on changing its magnitude. But what about the direction? Its direction is always fixed. Okay. The normal force is what? It is what kind of force? It is a pushing type of force. What normal does? It always push the body. Okay. It always, what it does? It always push the body. Okay. So it is also called as it's a pushing type of force. Clear? So it is always pushing the body and it is always acting what direction? It is always acting perpendicular to, always acting perpendicular to contact surface. Understood? How does, what direction it acts? It always acts perpendicular to what? The contact surface. And which direction? In the such a direction that it will push the body away. So if I write these two lines, it's a very what you can say, sir. Okay, we know these two lines, but how do we draw it in the diagram form? Because later when we will solve the questions, you have to draw these forces, whatever forces we are going to learn now in our today's class. We need to draw all these forces in a diagram form, and that diagram is called as what? The diagram is called as the free body diagram. That means we need to understand with the help of some example that how are we going to draw the normal force. Understood? So let's take some examples where the normal force is acting and let's see how the direction will come. Okay? So can we take some examples here? Can we take some cases where we will try to learn that? Let's see. There is a question given. There is a wall given to us. Okay? And there is a ground. This is the ground and this is a vertical wall. Okay, I'm going to keep an object like this. Don't worry about all other forces right now, just decide the direction of normal. Can you tell me how many normal will be acting on this block, on this book? How many normal will be acting on this book?
Two.
One, two, three. How many?
Two.
2. Everyone is clear? 2. Why 2? Because this object is in two contact. है ना? This object is in how many contact? There are two contact. है ना? This object is in contact with two different surface. So we are going to have the two normal. Okay. Let's draw those direction of normal. See how the normal due to wall will act. See that? Can I say this is the this is the contact surface? So normal will be applied perpendicular to contact surface. When someone is applying, the person can apply the normal due to wall like this also, or someone will say, no, no, sir, you only said perpendicular to contact surface. So this line is also perpendicular to contact surface. Can you tell me which is the correct direction of normal due to wall?
First one,
Towards
sir.
right or towards first one? Towards right. Why so? See, perpendicular to contact surface we understood, but one more thing we learn about the normal force, it is a pushing type. So this is the wall, है ना? And this object is in contact. So what the wall will try to do is the wall will try is this wall is going to push the object towards right. So that's why what should be the direction of normal force due to the wall? It should be towards which direction? Towards right will be the direction of what? Normal force due to the wall. Understand? Okay. Next, tell me. Can I say there is one more contact here with the ground? Isn't it? Ground is also trying to push the object with the help of normal force. So which way the ground is trying to push the object? Which way the ground is trying to push the object? Is the ground is trying to push it away, matlab up? Can I say this is the normal due to ground and this is the normal due to wall? Please tell me, understand these two things or not?
Yes, sir.
If mass of if mass of the block is m, can you say that there is one more force acting, sir? Please tell me. Can you tell me which is the other force or further acting?
Gravitational force.
Gravitational force. What direction gravitational force will be acting? mg. Which direction? Normal. Sorry, which direction? In the downward direction. So please tell me, do you understand? There is going to be three force acting on this block. You know what you have just now drawn? Can you tell me what is this diagram called
Body
as?
diagram.
Yes, you have just now drawn the free body diagram of this block. तो अभी till now we only learn about the two forces mg direction मतलब gravity direction we know, normal direction we know. So that's why we have drawn this. Later what will happen? This block will be connected to the string thread. This tension force I have to draw. Then after some time it will be connected with what? Spring. Then we need to learn how to draw the spring force. Okay. Next what? There will be a rough surface. So tell me what will happen? We have to draw the friction direction then. Understood? So like that one by one, we are going to learn about all these forces. Then what will happen once you are understanding all these forces, then it will become very easy to draw the free body diagram. And the moment you understand how to draw the free body diagram, your 50% of the question is what? Just solved by drawing the free body diagram. Later it is just what? Taking component and writing the equation. But the most important part is what? How to draw the free body diagram. Is that clear? Please tell me. Now, one question I am asking here. Please tell me which of the two forces action reaction pair here? Which of the two forces action reaction pair here?
MG and normal ground.
Mg and normal due to ground. Are they action reaction pair?
Yes, sir.
Okay, let's go back a little bit. That's why I said Newton's third law of motion is the simplest of all and at the same time the most difficult also. See that every action has equal and opposite reaction. Everyone remember, everyone understand. But now see the next three line what did I wrote? Action reaction pair always act on two different body. Can you tell me normal due to ground and mg is it acting on same body or two different body?
Same body.
So that means they cannot be action reaction pair. Next, action reaction pair are always of same nature. So if one is the normal, the other should be always also the normal type, isn't it? But here one is the normal, one is gravity. So that means what? They can't be of the same nature. Understood? So here none of the three forces are action reaction pair. Understood? Please tell me. So now if I want to show you what is the action reaction pair, let me help you. Okay? Please tell me. That's why I always prefer to explain what is the action reaction pair. Okay? Because that is the simplest thing and at the same time the most a concept where most of the student will make the mistake. Okay? So see, if I draw the free body diagram of the wall, if I draw the free body diagram of the wall, can I say whatever the normal wall applied on the block, is it going to experience the same amount of normal on the wall? Please tell me, do you understand? Let me write it in a little bit different way. Let me write it like this: normal due to wall on the block. Is it normal due to block on the wall? Please check it. Now tell me if I ask you, which is the action reaction pair? Now can you answer me correctly? Can you say, sir, this force, look at carefully. Can we say this force which is the normal due to wall on the block and this is the normal due to block on the wall? Are these two action reaction pair? Just check it. Is all the condition of action reaction pair is satisfied? Please check it. They are equal in
Yes,
magnitude,
sir.
opposite in direction, same nature of force, and they are acting on two different
Different
bodies.
body.
Understood? So, these are the three conditions needed for the force to be action reaction pair. Can you tell me what is going to be the reaction of this force where that reaction will be acting? Where that reaction will be acting? Can I say if I draw the ground? Please tell me. If I draw the ground, please tell me. If I draw the ground, is the ground is experiencing a normal, a force due to, tell me, is the ground is experiencing a normal force, right? Due to block on the ground or on the table, you can say that on the ground surface or table, and this is normal. What is this one written? Is it written normal? Is this written normal due to ground on the block? Please tell me, are these two again forming the action reaction pair? Please tell. And if I ask you, tell me reaction of mg, tell me the reaction of this force also. Let's say someone asks you in the question, where is the reaction of this force? You know where the reaction of this force is? The reaction of this force is acting on the earth. मतलब earth is pulling the block towards it with mg force. The block is pulling the earth towards itself with what force? Exactly same mg force. Understand or not? That means you are pulled towards earth, na? You are stick to the earth. So earth is applying a force on you. How much force? Your mass into z. So how much force you are applying on the earth? Exactly same, but in which direction? Opposite direction. So these two forces are the action reaction pair. Okay, please tell me, is that part clear or not? Where will be the reaction of mg? Can I say reaction of mg will be like this? Please tell me. है ना? Earth pulled the block towards itself with mg force, isn't it? Earth pulled the block towards itself with mg force. The block is pulling the earth what? With the same mg force towards it. Please tell me, do you understand the meaning of action reaction or not? Is that clear now, this concept? Please tell me. Is the concept of action
Yes,
reaction
sir.
clear? All of you, please tell me, do you understand or not? Or still
Yes,
any
sir.
clear? Okay. So now the next part we are going to discuss one, two more example where we will learn to draw the direction of normal force. Okay. So let's see the next example and see how the normal will be acting. Is that clear? See, let's say an inclined plane is there. Okay. There is what? An inclined plane is there. Some inclination is there, and a block is kept on the inclined plane now. Mass of the block is m. Up till now we know the two forces, isn't it? Normal and mg. So just tell me the direction of normal and mg here. So what we will do it, if I want to see what forces is acting, can I say this is the contact surface? Please tell me. Can we say this is going to be the contact surface? And from contact surface, is it going to be the pushed away? So this is the
Yes,
normal
sir.
applied by the incline. And what will be the mg? Mg will be acting in the downward direction. This is another example of what? The normal force, how we are drawing. Let's see one more example. In this question, what is given? Two books are given to us. Okay. Let's say the book number 1 has mass m1 and the book number 2 has what? Mass m2, and they are together kept on what? On a ground. Again, when I will give you this question, many students make mistake here. Okay, what is the mistake they make? Let me tell you. Actually, just draw the free body diagram of book number 1. Book number 1. What are the forces acting on the book number 1? Till now, I have only discussed the two forces, normal and mg. That's why I am not connecting these objects with the string. The third type of force I am going to discuss is the tension. After that, I will connect them with the string also. So tell me, M1, if I ask you what forces are acting, will you say the first and simplest force is the M1 into Z, gravity force,
One
downward direction,
normal due to
normal due to
M2.
M2. This is the contact surface between the M1 and M2. Check it. This is the contact. From that contact surface, is the block number 2 is pushing it away. So this is the normal. Let's call this normal as N1. That's it. These are the only two force acting on M1. Let me draw the free body diagram. This will be called the free body diagram of M1. Let's draw the free body diagram of M2. The first and
Z
simplest
force.
force is M2Z. M2 is having how many contact? Tell me. How
Two
many
contact.
contact M2? Two contacts are there, right? One contact is between M2 and the ground. So is the ground is going to apply a normal? Which way the ground will be trying to push? Is the ground is pushing it M2 upward? Always see the contact surface and see what side of the contact surface the object is lying. Apply the normal that side. Okay. Next, is the M1, sorry, M2 is in contact with this upper block also. What way this upper block is trying to do? Push it down. So N2. Should I draw it N2, or please tell me, can I write it? This is nothing but N1. Please tell me. Can you say this force
Yes, sir.
and this force, are these two forces are action reaction pair?
Yes, sir.
Understood? Please tell me, is the free body diagram of M2 is complete or is it missing something? That is the complete free body diagram of M2. Nothing is missing. Understood? Okay. Where the reaction of M1G will come? Reaction of M1G will come on the ground. Where the reaction of M2G will come? On the ground. Where the reaction of normal due to ground will come? On the ground. Understood? Because ground has applied the normal. Na? Understand? So, but ground, there is no use of drawing the free body diagram of earth. Hai na? Please tell me, there is no use of drawing the free body diagram of earth. Why? Because its mass is too large, isn't it? So if I push the earth, it's not going to go down, isn't it? Think about it. You're jumping on the earth. Is the ground is going down because of your application of force? No. So that's why practically we never draw the free body diagram of the ground. But if, let's say, a theoretical question comes and asks, tell me where is that reaction force? So you should be clear about that. Where is that reaction force? Clear? So this is about the normal reaction. Now we are going to go to the third type of force, and my third force is going to be the tension force. Understood? Tension has one property. It is a pulling type of force. What kind of force it is? It is a pulling type of force. Means whenever you apply a tension in a body, it means its only purpose is to pull the body. Understand? You cannot push a body with the help of a string. Means if you connect any object with a string and then you apply the force on the string, you will be always pulling the body, isn't it? So that means the tension force always does what? The tension force always pull the body. It can never push the body. Understood? So it is always what type of force? It is a pulling type of force. Next point about the tension force. It always acts which direction? It always acts along the string. Understood? It always acts which direction? It always acts along the string. That is another point about the string force or tension force. Second point. Now we have two type of string. One string is called ideal, other one is called non-ideal. So what does it mean by ideal string and non-ideal string? So ideal string means what? Ideal string means what? If a string is massless, okay? Ideal string means what? String is massless and inextensible. Ab you will say, sir, how is it possible for a string to be massless? We can never have any object which doesn't have any mass. So massless here in sense what? Let's say I have a string. whose mass is 20 gram. Okay, a very thin wire is there. Its mass is 20 gram, and I am connecting a 5 kg object with that. Please tell me, compared to 5 kg, what is 20 gram? Nothing, isn't it? So massless means what? Negligible mass. Compared to the objects, it is going to connect. है ना? Compared to the objects, we are going to connect with the string. The string mass is what? Negligible. And inextensible means what? Non-elastic one. Inextensible means what? That means generally what happens when we apply the force on a string, whenever we hang an object with the help of string, the string gets stretched. Na? String gets what? It gets stretched. Its length changes. But here, what kind of a string we are going to consider? Massless and inextensible. मतलब with the application of force, na, string length is not going to change. But you will say, sir, again it is not possible. Yes, ideally it is not possible. But if I say length of a string was 20 meter, and with the application of force, length got stretched by 1 millimeter. Please tell me, compared to 20 meter, is the 1 millimeter is any significance? Please tell me, compared to original
No,
length of
sir.
meter, is the 1 millimeter having any significance? No, isn't it? So that's why, for practical purposes, what we can do, we can consider a string to be what? Massless and inextensible. So what is the advantage of a massless and inextensible string? Once we know that I'm going to consider a string is massless and inextensible, then what is the property of a inextensible ideal string? So for ideal string, what happen? If a string is ideal, then if a string is ideal, we will discuss all the other cases also. If it is non-ideal, then what will happen? If it is extensible, then what will happen? But first, let's discuss about the ideal string. Okay, if string is ideal, you know what is the advantage I'm going to have? If a string is ideal, every point on the string, every point or part of a string, any small section of the string you consider, you will find the tension is what? Same at every point. But only for what? Ideal string. So if a string is ideal, every point or part of string, every string will have what? Will have same tension. Means throughout the string, the tension going to remain what? Same. Understood the first thing? Now, generally, strings are connected over a pulley. Pulley is nothing but just a disc shape. Understood? Right? You must have seen many cases like this, isn't it? A pulley is there, right? That pulley one side connected with one block M1 mass, the other side it is connected with another block M2 mass, isn't it? And this is called the pulley. Again, we are going to consider what kind of pulley first. First, we are going to consider an ideal pulley. Ideal pulley means what? Ideal pulley means what? Pulley is what? Pulley is what? Massless and frictionless. Frictionless means smooth one. Understood? If a pulley is massless and frictionless, what will happen? This will be called as ideal pulley. Again, how it is possible to be massless? Means the pulley mass is negligible compared to other objects which is connected with the pulley. Frictionless means what? As smooth as possible. Let's make the pulley what? As smooth as possible. Understood? So that kind of pulley will be called as what? Massless and frictionless. What is the advantage? So the advantage of that is what? Both side of the pulley. What is the advantage of that? Both side of the pulley will have what? Pulley will have same tension. Understood? If a pulley is massless and frictionless, means if an ideal pulley is given in the question, we will consider both sides of the pulley to be having what? The same tension. If it is having mass or if it is having friction, then we can't consider that. But if the pulley is massless and frictionless, we can consider both sides of the pulley having what? The same tension. Understood? So let's take some example and try to understand the direction of tension now. Can we discuss now? See, in this example, this is the simplest example I am taking. Just tell me what is the direction of tension. This block is M. Let's draw the forces acting on this M. The first force is going to be the simplest one, mg. Second force is going to be, can I say tension will be along the string? Is it how the string is connected? See that? Is it how the string is connected? Check it. So tension will be in this one. And what the string will be trying to do the block? Is the string is trying to pull the block? Tell me, look at the tension. Is the tension will try to pull the block? So that is the direction of what? The tension. The simple tension and mg, that is the only two forces acting on that. Clear? This is also called as the free body diagram of the block. Next example, let's see. Here only two forces we have. Let's see the another example. See that now I have discussed with you the three forces, isn't it? Till now what forces we have discussed? The three forces. Let's say this is an example given to us. A block is kept on the inclined plane. Okay, a block is kept on the inclined plane. It is a smooth surface given to us. Now they are asking what are the forces. How many forces will be acting on this block? Can you tell me? How many forces are acting on this block? Three of them, na? One will
Three,
be
sir.
mg downward. Another will be because of contact. There will be
Normal and tension.
and because of a string, this is the direction of the string. Can I say string will be pulling what? Away, isn't it? String is pulling the object, right? The tension force due to the string will be what? Right? You see, now it has become the free body diagram of this block. You see, the more and more we are learning, the more and more number of forces are getting involved in the question. Please tell, clear this one? Next, let's see another example of how to draw the direction of tension. Let's say an example given something like this. Let's take this way. Okay, this is the horizontal ground. Okay, this mass is m1 here, and same string is passing here with m2. If I ask you in this question, tell me what are the forces acting on m1 and what forces are acting on m2. Please tell me, what is the forces acting on M1? Is that going to be M1G? There, there is a contact here. So can I say there will be a normal due to ground acting? And this a string is connecting here, na? So can I say this is the direction of the string that will be trying to pull it? That is the tension force. Understand? These are the three forces acting on the block. M1, normal, mg, and tension. And if I ask you, tell me same way, what are the forces acting on M2? So M2 will have two forces only, isn't it? One will be M2Z
Additional four.
downward, and there will be a force tension. Check it. Can I consider tension acting on M1 block and tension acting on M2 block to be equal? And why I am considering them equal? Because this is connected, M1 and M2 are connected with the help of same ideal string. and it's a passing over what? An ideal pulley. It's a passing over what? An ideal pulley. The ideal string says same tension throughout the string. An ideal pulley says even a string pass over two sides of the pulley, both sides will have the same tension. So please check it and tell me, do you understand about the direction of tension now?
Yes, sir.
Yes, sir.
So this is about the direction of what? The tension, which is the third force. Now my fourth force is going to be what? The spring force. Okay, what is going to be my fourth force? Is going to be a spring force. So please tell me, what is going to be the spring force? What kind of force is a spring force? Pulling type or pushing type? What kind of force is a spring force? Does it pull the object
Push
or
type.
does it push the
Push,
object?
push up.
Think about it.
Depends,
Think,
sir.
think.
Depends, sir. If we compress it, it will push it. If we elongate it, it will pull it.
Yes. So you see, isn't it a combination of kind of tension and normal? Normal was always pushing the object away. Tension is always pulling the object towards itself. And what spring does? It can push as well as it can pull. It depends on whether we have compressed the spring or we have elongated the spring. Please tell, is that part clear?
Yes, sir.
So it is what? It is acting in both way. So how do we decide when it is pulling, when it is pushing? So for that I need to check, did my spring is in compression state or my spring is in elongation state? Okay, without knowing that we cannot answer that it's a pushing the object or pulling the object. Understood? So it can pull as well as it can pull as well as push the object which it attached. Na? Push the object. Clear? And again, ideal spring means what? Ideal spring means massless spring. Okay, na? Inextensible, so I cannot say that spring is there, it is not getting extended. What is the purpose of a spring then? Hai na? So ideal spring means what? The massless spring. Now I need to check this spring is elongated or compressed. That means, can I say every spring is going to have a what? A natural length. Can I say that? This is called the
Yes, sir.
natural position. Okay, natural position of the spring. Natural position means what? The position of the spring when it is neither elongated nor compressed. That position is called what? Natural position. And what is the length of a spring in that situation? That is called the natural length of spring. Understood? Please tell me, clear about the natural length and natural position?
Yes, sir.
Please tell me, clear? So natural length of a spring means what? The length of a spring without elongation or without compression. Clear? Every spring has its property defined by the K. That K is called as what? The K is called as spring constant. What is this K called as? This K is called spring constant. Okay, spring constant. Some question you will see the word written as force constant. Sometimes they will use the word stiffness. Stiffness of a spring. Matlab this K decides how easy it is for the spring to get compressed or elongated. Understood? So if K is more, what will happen? It is very difficult to elongate or compress. And if k is less, then what will happen? It is very easy to elongate or compress. Okay. So next thing we are going to learn about this direction of forces. And the moment we are learning one of the force, we are drawing it in the diagram form, which is called free body diagram. The force, different type of force, and how these forces are acting, we are learning side by side. So next class we will have it on the Monday for the mechanics. Okay, na? For next 3 days we have the electromagnetism part. Okay, everyone. So next class when we will join, what we are going to do, we are going to discuss about the spring force, how it will be acting, and friction force we will learn. And after that, we are going to draw these forces in the free body diagram and calculate their magnitude. Right now, we only know the magnitude of only one force, the gravitational force. How much is the magnitude of normal tension? We don't know yet. So we will learn how to find those magnitude. So please tell me, are you clear about what we discussed till now? Please tell me.
No, sir.
Right. So let's join it tomorrow. Tomorrow we will have the electromagnetism part. Okay. So good night. Take care.
Thank you, thank you, sir.